Hi everybody, can you hear me? I hope so. Oh my goodness, this has been so miserable. So, gosh, where do I even begin? So, I mean, my foot stuff aside, where I injured my foot last week and couldn't do anything. And like I couldn't even sit in a chair. Okay, good, people can hear me. But I'm like, okay, great. I can walk again. Everything's gonna be great for a lecture. So I sit down on Monday, get everything set up, realize, oh, I need to reboot the computer because otherwise my drawing program, this thing that I use here to draw on the screen, is real laggy if I don't actually reboot the computer. So I did that. And when the computer reboots, the monitor doesn't reboot with it. It's just completely white. And I can't see anything. And that's my secondary monitor that I put everything on. So, like, my PowerPoint's on the main monitor, and then, like, all of the production stuff that goes on behind the scenes. I mean, let me see if I can actually show you. Like, this is what my screen looks like right now, where this is the production screen. And so I'm using this thing that I'm moving around that has the thing superimposed in it. That's all on the second monitor, and that doesn't exist right now. So the issue I'm going to run into really quickly is I cannot see the chat. You can see the chat because it's posted on your screen and it'll be captured in the video, but I have to alt-tab between things and find it. So I apologize if I don't get to your questions right away. It's because I don't immediately see them. I will do the best that I can for today, but after this lecture, I have another lecture, and after that, I am immediately just going to go and buy another monitor because this one just broke, and I can't function without a second monitor. So, yeah. So I apologize for all the technical delays and getting started 20 minutes late. I have it functioning enough, so we'll get started here. I put videos up last week that stopped you right around here, where we were talking about significant figures. Now, obviously, you didn't have any direct feedback from me on questions for the first chapter or the part about imperial metric units. I am going to assume that you've watched those videos. If you have any questions about Chapter 1 or the first bit of Chapter 2, please feel free to ask them in the Discord. And then for today's lecture, from here on out, we're going to be doing these lectures as scheduled or intended. And if you have questions about those, let me know during the lecture as questions come up. Okay? All right. So the first thing that we want to do is talk about how numbers work in terms of making a measurement with them and then representing what that is. Because a measurement is going to be some sort of value that we acquire by using some sort of tool. Now, importantly, the definition of what the tool is very important here. So, for instance, if I have a ruler, and let's actually switch over to the ruler, or to this view here. We'll move this so that we can see what we're talking about. And so I'm going to draw a ruler here. Not with the text box, though, but... Alright, so let's suppose I have a ruler here. And the ruler measures in, like, centimeters, and so it goes like this, do. And so we'll say 5, 6, 7, 8, 9. And I have an object, and it measures from the beginning of the ruler right to here. And you could say, well, that's like 6.5 or so, right? But what exactly do we get to write down? Do I get to say it's 6.5 or 6.6 or whatever? Like if I wrote this measurement down, you might say, okay, that's reasonable. But is this reasonable? Or this reasonable? Or this reasonable? Like, what number do we write down for a measurement? Like, where's it okay to stop based on what the ruler tells us? Do I know exactly where this point is on a ruler? And the answer is, well, no. These numbers are sort of just guesswork, right? Because I can't tell what the next digit is past 6.6 because I don't have other marks that help me resolve that, right? If you have lines on a ruler, the lines help you figure out what something is to more precision. However, you need to have progressively smaller and smaller and smaller and smaller lines to help you get those next digits. So, when we are looking at numbers on a tool, this word right here, exact, is very difficult to use because you almost never know exactly what you're measuring. And this is because all tools are inaccurate. They only tell you so much information, right? When you call somebody a tool, it's because they don't know what they're talking about, right? That's because tools are inaccurate. They don't give you the whole picture. They do the best that they can. They're trying their best. So if you make a measurement, we'll just go down to this one right here, with a device. So that's a tool such as a ruler, a beaker, something that you are measuring against, a thermometer scale, for example. The result that you are going to get is what we would call an inexact number. And for an inexact number, there is some estimation involved. In other words, if I say that it's 88 degrees Fahrenheit out, it's not 88 degrees, what am I saying? It's 55 degrees Fahrenheit outside, which is insane for the winter. But it is. It was 55 yesterday or tomorrow or whatever. I checked my weather app. If I say it's 55, does that mean it's exactly 55.00000? No, I rounded to the ones place, right? If I say it's 55.2 degrees outside, then I know it to much more precise detail, right? Yeah, this is Chem 121. If you're in my Chem 140 class, your lecture's at 2:30. Provided that something else on my computer doesn't explode. So, apologies for that. So any number that we generate from a ruler will be inexact. There will be some error with it. If I stand next to one of those, like, I don't know, height strip things that are like, that you would see, like, behind a prisoner when they get their photograph, or next to the door on a convenience store. If I stood on one of those, I'm 6'0", but I'm not exactly 6'0". I'm probably a little bit above or below the line, right? So my height is an exact number because it's measured using a tool, the tool being a ruler. Now, are there any circumstances that you can get an exact number? And the answer is you can only do that if you're counting or defining. Now, what do those terms mean? The first one's straightforward. What does it mean to count something? How many fingers do I have? 1, 2, 3, 4, 5. I can count them. I thought about going 1, 2, 3, 4 and then just stopping, but I thought that might confuse you or concern you. We've had enough chaos today. So if I count something, just 1, 2, 3, 4, 5, 6, whatever, there's no error there. Because we have defined a counting system to be exact. There are exactly 5 fingers on my hand if I count the thumb as a finger. How many people are watching this video right now? Well, if I go back to this, if I can find it here, there we go. I move this out of the way, we can see that right here, there are 22 people watching the lecture. That's an exact number. There are exactly 22 people here. There is not 21.8 people watching the lecture. That doesn't make any sense, right? You can't have fractional people. So those are examples of exact numbers. There are exactly this many things because I have counted them. The other example of an exact number is a definition. A definition is exact because we said so. 1 gram is exactly 1,000 milligrams. Why? Because we created the units with that concept in mind. Okay? Those are going to be exact numbers. And those are the only two circumstances that we will see exact numbers. I counted it, or you counted it, or somebody counted it, or we defined it. We're taking a definition out of a textbook or off of the internet or off of Google, and we're doing that. Now, why do we care about exact and inexact numbers? That's going to come up in just a second. So when you see a value, you should be looking at it and thinking, okay, that is an inexact number because of how it is measured. So that's the sort of thought process you will want to get into. All right, so let's look at an inexact number here. I'm going to put a ruler on the screen here, and I'm going to put a different set of markings than I did before on the little sketch that I drew. What I want you to do is I want you to tell me in the chat how long this object is. What would I write down for its measurement? So if I was given this object and this ruler, and I line them up at 0, and this is where the object stopped, what do I report to my supervisor as the length of this steel beam, for example? Okay. I want you to type your answer in the chat. Make sure you include a decimal point in your result and the units. The units are centimeters, as you can see. And I want to collect a few guesses. So type out what you say. I'm going to go quickly get more water because I drank it in frustration dealing with my computer. And we're going to tally the results and see what we get. Okay? See you in a bit. All right, very good. We got a ton of guesses here. Now, I see a bunch of numbers that are more or less similar. However, they all sort of vary in the last digit. And then there's some people who only wrote 3 digits at all. So obviously there's some differences in how people think to measure, right? And that's why in science we have this conversation about exact and inexact numbers. Clearly this is inexact, right? Because everybody's coming up with a different number. So how do we resolve this? What is the correct number to write down? And is it inexact after all? Well, it's absolutely inexact because we're using a tool to measure it. And so if I go like this, and I don't know if this will work. Yeah, there we go. We're going to just zoom in on that a little bit so that you can see it a little bit better. And so what I would say is that this is a little bit less. Oh, I can't actually write zoomed in like this, so I have to go back. I would say that this mark right here is between these two lines, first of all. And since this line right here is 11.6 and this one's 11.7, I know that it is at least 11.6 something, right? I could write that like this, 11.6 something. These numbers right here, the 11.6, are known for sure. Right? We're certain of those. It came after the mark, this is 11.6. There's no way that it's something different. However, this last digit is estimated. there's no lines that tell us what it is. All we can do is gauge relatively where it is between 11.6 and 11.7. And because it looks to me that's a little less than halfway, I would guess this. However, maybe you're thinking to yourself, no, there's no way, that's exactly halfway. And so you wrote, that is your measurement. These are both in centimeters. It turns out that those are okay. The last digit in our measurement was estimated to some degree of certainty. However, we can never know for sure. That should say certainty. There we go. We can never know for sure because there aren't marks that tell us. So what numbers are appropriate for that last digit? Well, the last digit can vary, so we decided that 4 was appropriate. But if I measured this and I said 11.60, you might look at that and go, well, wait a second, that's not right. 0 would fall on the line. Likewise, if I said 11.69, you'd look at me as if I was blind, right? So there is a series of numbers that are okay. And those are numbers that fall in the middle. And you can pick any of those numbers because the last digit is estimated, and this value is inexact. So when we take a measurement, the last digit will have some guesswork involved. Now, to reiterate the process that we just went over here, let's use this algorithm to get to the same result roughly every time. There may be, again, some variance in the last digit here, because remember, that's estimated. But here's the algorithm that we're going to use. And we're going to have you use this algorithm on the next few examples as well. So here you go. Step number 1, write down the digits that you know for sure, based on the lines on the ruler that your object falls between. Remember that it fell right here? So I know it's at least 11.6 something. So these are the numbers I know for sure. Once you've written down all the numbers you know for sure, the next step is to guess one more digit, only one. And do the best you can. So, again, if you said, oh, I don't think that it's actually 4, I'm going to guess 5. That would be okay. If you guessed that it was 6, probably still okay. If you guessed that it was 3, that's okay too. But if you guess things like 9 or 0 or 8, you're getting a little too far off for it to be considered to be correct, right? Sorry, I'm opening my seltzer water. I have a seltzer addiction. And that's how we measure numbers using devices. In the medical profession, this will be very important because all syringes have gradients on them. And in terms of medical practice, you want to make sure you get the correct dosage every time, right? So if you're supposed to administer 3.6 milligrams of something per deciliter or something like that, and you have a syringe or some sort of gauge that measures in ones, you could easily do that. You say, okay, I'm a little above halfway. That's 3.6. There you go. Okay? We're going to apply this technique to every ruler we see, starting with these. So what I'm going to do is we're going to zoom this in. Oops, that's not how we zoom. There we go. And on the screen is ruler A. Using ruler A, what I want you to do is tell me the measurement that you would write down to report its length, okay? Now, use the marks as shown, because in a second here, we're going to get ruler B, which has got a different set of marks, and you're going to see how your result differs, okay? So, using your algorithm that I just gave you, tell me the length of the object measured on ruler A. All right, I've got some answers coming in there. There we go. Now, as I see everybody typing in their answers here, all of your answers are correct, even though they're not the same answer. As long as you have units, make sure to add your units on there too. So let's go over what we would say is the example answer for this. So here's where my object falls. I'm going to write down all the numbers I know for sure. So it's between 4 and 5, so I know at least the 4 is true. And then I'm going to write down the next digit. There you go. So very good. Now what I want you to do is I want you to do the same thing for ruler B, but you'll notice that ruler B has more marks on it. So I want you to tell me the length of the object shown here for ruler B. And I'm going to do this in the chat here to just separate out the ruler A from ruler B. So everything past this line is ruler B. So go ahead and type in your guess for the length of this object here. And I got to make sure that that captured correctly. Yeah, it did. Okay, cool. Now, what you're noticing as the answers come in on the chat here, you'll notice that everybody added an extra digit, right? And the reason that you're able to do that is because of those extra marks there. So, you now know the proper technique for making a measurement. And the number of digits you can write down is entirely dependent upon the lines on the ruler, or the syringe, or the graduated cylinder, or what have you. So, what I would say for this measurement right here, unfortunately I have to zoom out to draw on this again, but it looks like it's a little past midway, so I would write, it falls between 4.5 and 4.6, so I write down 4.5. And then I guess the next digit, and I guess it'd be something like that, right? I think I wrote down 4.55. Yeah, there we go. But close enough for government work. And this is a union job. So depending on the number of gradations that you have on your tool, you can get a more precise measurement. And by more precise, what I mean is you get to write more numbers, okay? So the number of digits that you write down in your answer is going to matter in this class and your profession. You don't want to assign extra numbers just randomly. If you wrote down that a patient's mass, or their weight, was 151.0653 pounds, that's a very precise amount of mass. That would change if they, like, brushed skin off of their arm, like, just like, I don't know, just like dead skin cells. Like, that would change their mass at that level. If you write down that a patient's mass is 100 pounds, because you rounded down from 135, that could be a real problem when you accidentally give them too little medication, right? Because medication and body mass are related. So the number of digits that we are writing down here is very important. Now, if you've ever used a calculator before, which you have, and you've done like 22 divided by 7, you've probably noticed that the calculator just fills the screen with a bunch of digits, right? It will divide forever and ever and ever. Likewise, if you multiply by a decimal, you generally get tons and tons of digits, right? What we're going to have to do, and that's going to be the purpose of today's lecture, is we're going to have to figure out where do we stop writing digits, because the numbers that we write down are important and have meaning, okay? That's why we only wrote 3 digits here and why we only wrote 2 digits here. So that's our goal. The number of digits that you write in a value from a measurement is known as the number of significant figures that the measurement has. So in this instance right here, I wrote 1, 2, 3, 4 digits. I was able to go down to the hundreds place based on the ruler measurement that I made 2 slides ago. So what I would do is I would say, well, I wrote down 4 digits, so there are 4 significant figures, or Sig Figs. Any digit that you reliably know, so again, remember that these first 3 digits were reliably known, i.e. they were certain because the object went past that mark. And the last digit was estimated. If your digit is reliably known or estimated, we count it as a significant figure. If it's totally made up, it's not a significant figure. If you have no idea what it is, it's not a significant figure. That's why we don't write the zeros past this, because they're not technically zeros, right? Now, the more digits that you write down, the more precise your answer is. So, for instance, if I had a better tool that measured this distance, this is not something you can achieve. I was trying to say attain, and I said achieve, I guess. I don't know. This is not something you can achieve with a ruler. Something this good of a measurement, you need like a laser-guided nano something. I don't know. You need a computer. A computer could do this because computers are constructed with the intent of being very, 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 very precise. And so this number right here, I know all of these digits, and my marks go to this spot. Whatever this is, tenths, hundredths, thousandths, 10,000ths, 100,000, the millionths place. So I have marks at the millionths place, and then the object falls halfway between those marks at the millionths place. So if I knew all those numbers and then estimated that last digit and this was my result, because there are 9 digits here, I would have 9 Sig Figs. Now, you might be looking at this and just saying, well, I'm just going to count all the digits, and that's how many Sig Figs I have. And most of the time, that will work. More digits, the more Sig Figs there are, the more precise the value is, the better known it is. Now, counting the number of Sig Figs is going to be a task in and of itself, which we're going to get to in a second. Because if you're making a measurement and reporting the number, like these numbers right here, then that's great. You know what the tool was because you made the measurement. If, on the other hand, I made the measurement and gave you a number, which tool gave you that number? So let's work backwards and try and do an example of that. I measured this volume of water, 540. I want you to tell me which graduated cylinder did I use, A, B, or C? And then, how do you know? Type your answer in the chat. Did I use graduated cylinder A, B, or C? And then try and think to yourself, or maybe even write this down, why did you select the answer that you did? You can type that in the chat if you want, but that'll probably be a longer answer. All right, we got a bunch of answers that came in. A bunch of people said B. And it turns out the correct answer, surprisingly, is B. No, you're totally right. And some students attempted to explain their answer. And because we're new to this topic, it's probably hard to like eloquently describe what you mean. Because I could see that you're on the right track. But what do the numbers mean again that we've written down? So here I have 540. And this 0 is what's going to throw everybody off here, because you think, oh, well, there's a 0 there. That's a known digit. Well, it turns out, if we're rounding to the tens place, so round here, that 0 comes along with, right? So this 0 is rounded off. And that's what's going to cause a little bit of confusion in figuring out sig figs in a little bit. But that's why we're doing this example here. So let's follow the measurement rules that we established on the previous page to try and get the right answer. So the first thing we're going to do is we're going to write down the known digits, right? And that's going to be dependent on the marks here. And we're going to do graduated cylinders A and C at the same time here. Okay. Let's just look at graduated cylinder B for this example, and then we'll go back and do A and C and see what happens. So for graduated cylinder B, I know that there is going to be at least 500 milliliters in here, right? So I would say 500. I just don't know what those next digits are. And then what's step 2? Estimate the next one digit, right? Okay. That would be this. And this is where you say, okay, I'm going to estimate that it's 4. And so that's the answer I'm going to report. This is the volume of the graduated cylinder, right? And you immediately are probably going, well, no, that's not even close, right? 54 is not the same magnitude as 540, right? So what does the 0 mean? We're delving into number theory. This is probably not where you thought our chemistry class would go, right? That 0 is what is called a placeholder. Placeholders are important because without them, you get numbers that have the wrong magnitude, right? 54 and 540 are not the same. If I owed you $540 and I gave you $54 and said, well, the 0 doesn't mean anything, and then walked away, you'd be like, hey, wait a second, you son of a bitch, right? Ripping me off. So that 0 means something, and we need to include it, or otherwise numbers don't work, right? However, we don't know its value. We're only tagging it on there because we had to round to the tens place. So later on, when we start writing out numbers and we see a bunch of zeros everywhere, 0 is going to be important because 0 will not be a sig fig if it's used in this way. In other words, that placeholder 0 does not count to the number of sig figs that we have. So there's only 2 sig figs in 540 because only 2 of the numbers are known or reliably estimated. Like we said right here, known or estimated. That 0, we have no idea what it is because all sorts of values could round to 540, right? If this is my rounded result, then any result between these two ranges would get there, right? And in the ones place, that could literally be any digit we wanted. So we're going to just report that number with a 0, and we're going to assume that the 0 is it's random. It could be any number. Who knows? All right. Let's use the number rules or measurement rules to get values for these other two graduated cylinders here. So here on graduated cylinder A, 0 is at the bottom here, and then 1,000 is at the top. Now, if I look between the two marks, what I would say is that there are marks every 1,000, right? So I would know that I have 0,000. So the first digit is 0, which is my known digit. And then the next digit would be my estimated digit. And again, this is graduated cylinder A. And I would estimate, well, it's halfway up the graduated cylinder, so this is its volume. But then I need my placeholders because I need it to be in the hundreds place. And so we would just do this. And then finally, what we do is, well, nobody writes numbers like this, right? We're not in the military here. We're not reporting it as a time. So we eliminate or erase. If I can click on this, why is this not working? That first value. And then that would be our measurement. 500 milliliters. And we would say this is the only Sig Fig in it. So we got 500 here. We had 540 here. And then here, we're going to have the same sort of process. Oh, I hate when PowerPoint does this. So let me erase this real quick, because I just don't want to erase all the ink on the slide here. All right, so we're going to write down the known digits, so we know it's at least 540 for C. 540 something, right? And so these are known. And the next digit is estimated. And I would estimate it to be, well, it's about halfway, maybe a little less. I would guess that. And so you can see as the number of marks increases by a factor of 10 each time, you get the next digit down. So this one I only got 1 digit, this one I got 2, and this one I got 3. And if you have to work backwards because this is the only information I give you, you can then imagine what the tool looks like. All right, let me tab back to see if there's any questions here. So people correctly identified that they were placeholders. And that's good. All right, let me know if you have any questions about this, because this is not an intuitive topic at all. This is a very different way of thinking about numbers. But it's important that we establish these sorts of rules so that we get precise and consistent results every time. When we're training you to be either nurses or healthcare professionals or whatever it is that you're going to take 121 and continue through the series for, we don't want you to administer different amounts to patients. We want you to administer, no matter which nurse the patient gets, we want them to get the correct amount of dosage of medicine, right? And so that's why we're going through these sorts of rudimentary foundational topics. All right. Now, we're going to talk a little bit more about placeholders in a second here, but we are kind of at break time. Normally, we would go for about 50 minutes, but because I started class 20 minutes late, I sort of went for about 40-ish. So we're a little bit later than our break normally would start, but I do like to have a break in the middle of the period. For C, is there's 3 sig figs? Yes, there are. Because we were able to write down 3 digits that were known. So these first 2 were known, and then this last one was estimated. We estimated it to be a little less than halfway. So when we come back from the break, so here's what I do. Actually, you guys know this because you already watched the videos here, so I'm talking to everybody like it's the first time I've talked to you, which it kind of is, but... So I'm going to start the break timer. We do break for 10 minutes. Go ahead and get up and stretch your feet, get more water. Don't break your second monitor. Otherwise, everything falls apart. I'm going to turn the music on for Paradise Killer here. And we will see you in just a bit. All right, we're back. I hope you enjoy that soundtrack. Paradise Killer is a very good game. Even if you just play it for the music. Oops, I gotta get rid of this timer on my screen. Hold on. There we go. Okay. Does that look correct? Yeah, that looks correct. Okay, great. Let's keep going. All right. Now, like we did in this example over here, I unmuted myself, did I? Yeah, okay, my mic is on. Okay. Like we did in this example over here, where we had this number and we had to look at what the number meant to imagine what tool was used. Generally speaking, you're just going to be handed numbers. If I give you this number or this number, those are very different tools, and we need to interpret what tool did what and how good it was at making measurements based on the number of digits that are written down. And so we need to count the number of Sig Figs in a number that we've written down. And we have some rules for that too, which we're going to go over here. So any digit that we write down that is not a 0 is always significant. And the reason for that is if it's known, we write its value. And if you know it, you're going to write what it is. 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, is it possible to know something is a 0? For example, if I have a ruler that measures like this, 1, 2, 3, and I land right here on the 3. I tried to land right on the 3, but I didn't. Could I write 3.0? And the answer is yeah, you could totally do that. So 0 may or may not be a significant figure, and we're going to have to figure out when it is a sig fig and when it's a placeholder or some other sort of deal. So that's our goal here, is when is 0 a sig fig? On the previous examples here, we talked about how this 0 right here, oops, why isn't this working? There we go. We said that this 0 was placeholder. And we also said that placeholder zeros are not sig figs because they represent a rounded quantity. Not an estimated quantity, but a rounded quantity. That 0 could be any digit before it was rounded to be a 0. So here's an example of needing placeholders. And I already used the money example here. If I owed you $3,996 and I rounded it to 4,000, then I said, well, these zeros are just placeholders. They don't mean anything. You'd be a little upset with me, and I could not rightly criticize that. Those zeros, the placeholder zeros, are needed so that we push the other number into the correct place. This 4 has a value of 4. 1, 2, 3, 4. That's what 4 means, right? But depending on where you put the 4, whether it's in the tens place or the ones place or the thousandths place, that gives it a different magnitude, right? So the placeholder zeros adjust the magnitude of your answer. So you do need them, or else numbers don't work. We cannot numbers without having placeholders to manipulate our numbers. However, even though they're necessary to properly use numbers, they aren't significant. And that's because they're rounded. So here's some more examples of numbers that we have measured out and have placeholder zeros here. So for instance, this first number has 3 digits that are known, and then all the rest of the zeros were rounded. You can think about what device would be used to make this. Remember, the last digit is estimated, so we would guess this one, and it would be this position where our numbers would be marked to. So these would be marks every, let's see here. 1, 2, 3, 4, 5. So every 100,000 there would be a mark. It would look something like this. So 1,100,000, 1,200,000. And our object here, since this was a 5, this is where the object would fall, is right in the middle. And so we'd write down the first numbers that were known, so we know these numbers, but the rest we don't know. And then we would estimate the next one digit as that. And then all the remaining zeros are just placeholders. That's the theory behind what we're doing here when we're looking at these numbers. Now, you're going to intuitively just do this by following these rules. Oh, what are the placeholders? I'm just going to get rid of them. And they are not Sig Figs. You don't have to break it down like this into these elementary steps every time. But I'm doing it so that you have it on a video and you can review it, just so you can understand it. In the next example right here, these zeros are also placeholders, even though they come in front of the digits. And the reason that they're placeholders is for the same reason. I need to push these numbers into the correct magnitude. This number as written is extremely small, right? It's a fraction of a thing. But if I get rid of these zeros, now it's a very large number, right? 4,386 is quite large compared to 0.00004386, yeah? So if these digits are known, then these over here must be placeholders. And when you're counting Sig Figs, placeholders do not affect your number of Sig Figs. Now, the shortcut method of this is to do the following. Instead of drawing in all these tools and trying to envision it that way, what you can do is put your hand over the zeros. In my case, I'm going to scribble them out. And you want to ask yourself, does the magnitude and the value of the number change? Is 1,250,000 the same as 125? Well, no, they're different. The magnitude changed when I got rid of the zeros. If the magnitude changes, those zeros were placeholders, and they're not Sig Figs. So if I write down any number, like this, you'll notice there's another zero in the middle there because I'm trying to give you different examples with zeros in it. And I go, okay, if I get rid of this zero, does the value change? It does, so this zero right here was a placeholder. Now, if you get rid of a number in the middle, that doesn't really make any sense. You can't get rid of numbers in the middle, right? Because 308 does not just collapse into 38 because the zero doesn't mean anything, right? In fact, if I know that this is an 8, then I know that this is a 0, right? So that's going to lead us to the next example, which is, what do you do if you have zeros that aren't at the end? What if they're stuck in the middle somewhere? Well, going back to our example here, the last zero here was a placeholder because getting rid of it changes the magnitude, right? But this zero is known because I know that this 8 belongs here because it is a known digit or estimated. It could be estimated. But if I know that 8, I automatically know the number preceding it is a 0. And I know the number preceding it is whatever it is, and so on and so forth, right? Because if I know my value if I know my object has a value of 308, there's no error in this 0 right here. I know it has to be 0 because if it was a 1, it's not 308. It would be 318, right? If it was a 5, it would not be 308. It would be 358. So that 0 has to be a 0. So I know that that value is what it is. Well, if I know something is what it is, it's a significant figure. So zeros trapped between other numbers are known, and thus are significant figures. So let's look at some examples like this. This is Jenny's phone number if you've heard the song. 8675. I'm going to get a copyright strike because I'm on YouTube. So I won't sing the rest of the song there. But you'll notice that actually, most people are probably too young to get that reference, but that's okay. You'll notice that there's a bunch of numbers that are known here, and then there's the 0 stuck in the middle here. And then there's a bunch of zeros over here. These are all placeholders, as we've discussed. But this 0 is known because I know the digit after it. The 9 is also known. I can't have a value of 8675309 unless that digit, the second to last digit, is 0. Also, they tried 8675319, and I guess it didn't sound as good. Or whatever. Now, for all of these, the intent is that at the end, we're going to count the number of significant figures here. So, counting all these digits, there were 1, 2, 3, 4, 5, 6, 7 Sig Figs. The zeros, the placeholders, are not counted as Sig Figs again. All right, so we've dealt with zeros that are buried in the middle. We've dealt with zeros as placeholders. There is one last instance of 0 as a placeholder. And we're going to look at this ruler right here. So this is a ruler that measures, let's see here, 1, 2, 3, 4, 5. So we're going to do something like this. 1.8, 1.9, 2.0, 2.1, 2.2. And my object is going to fall right here. Actually, I don't want to do green because that's red-green color blindness is a thing. So we'll do that. My object falls right there. Lands right on a line. And if I were to use my rules for measuring objects and writing down the number of digits, we would say, okay, well, what marks does it fall between? Well, it sort of falls on marks, right? So I would say if it whatever mark it falls on, and the mark after that would be what it fell between. So I'd write down the digits that I know, and then I would have to guess the next one digit. And my best guess in this case would actually be a 0. We'll just say that. If I write down this number, how do I treat this 0? Is it known? Well, yeah, we estimated it to be 0, right? Is it a placeholder? If I scribble it out, does the value change? Well, no, it doesn't actually, because 2.10 and 2.1 have the same magnitude, right? So what that implies is that that 0 was written there because it was known, and not because it was needed to force the value to be some magnitude. Now that song is stuck in your head. I'm sorry. I know who the students who are my age are now. Hooray. Or that like oldies. It seems weird that songs like that were in the 80s or 90s or so that were playing a lot are oldies now. Growing up sucks in some ways, so enjoy that. You have that to look forward to. All right. So here's the decimal rule. The decimal rule deals with situations where you have all these extra zeros that are like, well, why did you add these here? And the answer is we added them because they're known. So here is how the decimal rule works. The first step in using the decimal rule, find the decimal point. Oh, there it is. We found it. Okay. If you have the decimal point there, you must use the decimal rule. So this is mandatory when a decimal is present. This is not an optional rule. You must follow the decimal rule. So step 1, find the decimal point. There it is. Step 2, any digits that are non-zero, draw an underline. Boop, there you go. We know that these are Sig Figs, so there are going to be at least 4 Sig Figs in this value. But which zeros are Sig Figs and which zeros are not? And the answer is, for step 3, everything to the right is a Sig Fig. Everything to the left is a placeholder. So I just do this. I just keep checking off to the right. And so if I was asking you how many Sig Figs are in this value, I would say 7 Sig Figs. The reason for that? Those 4 digits are known. The other 3 zeros that come after it are also known because they're not placeholders. We wrote them for a reason. If we didn't know what they were, we wouldn't write them. All right. So those are the rules for counting Sig Figs. So you're going to be given a bunch of numbers that you just look at like this, for example. And I've color-coded them here, red and blue. And your job is going to be, tell me how many Sig Figs the numbers have. All right. So I have some examples here and some homework practice from the textbook here. But what I want you to do is, for each of these numbers, I'm gonna label them. So we're gonna say A, B, C, and D. For each of these numbers, consider the value as written. So I wrote 900. I wrote 90,210, which is actually a zip code. What I want you to do is pretend all these numbers I've written down are measurements. Based on the number that's written, how many significant figures are there? Okay? And then type your answer in the chat. And we're going to go over the answers together in about 3 or so minutes. Okay? I'm going to mute my mic, give you a second to type in your answers. The letters are there to help you type in your answers, like A is whatever you think it is, and so on and so forth. See you in a bit. Oh, I thought it was snowing. It's just the car. All right, one more minute and we'll go over the answers. All right, let's go over the answers here. If I can find my stylus, there it is. All right, so I immediately went over to the to this thing, and I didn't actually put this on the screen. All right, so let's get rid of this. All right. So the first number was 900, right? All right. Normally I could see it, but now I can't because I only have one monitor. So, as written, this digit is obviously a sig fig because it is non-zero. What is the purpose of the other zeros, though? Well, if I were to do this, and get rid of them completely, 900 would become 9, right? Well, so those zeros that are shown there must have been important to make the magnitude of that 9 be the correct magnitude. It should be in the hundreds place. And that's important just for how numbers work, but they're not actually known. And so we would say that there is only one significant figure in 900. Oh, I have a very important announcement. I don't know if you can hear it, but hold on. Say hi. Say hi. Maya. Maya, say hi. There we go. Okay. There we go. Maya loves everybody, especially when they are talking. So that was Maya, who's going to sit here and now just meow at me because she must have just woken up and heard that I was talking to students. So Maya loves everybody. All right, what's the next number here? We got 90210, or as I like to affectionately call it, 90,210. I have had this joke in my slides for like 20, not 20 years. I haven't been teaching for 20 years. What am I saying? Like 12 years, actually. And apparently they remade this show. Like, they brought back 90210, so I can't say ancient and terrible anymore, but that's apparently a thing. All right. The numbers that are not zero are significant. We've got a trapped zero, which is significant as well. But then this zero right here is a placeholder, because if I get rid of it, the value of the number is shifted over. So we would say that there are 4 significant figures in 90,210. All right, I got to get the other 2 ones up here, so we'll do that. Oops. Oh, and we'll do this just to have that on the screen there. All right, so 0.0870. So I got to scroll down a little bit here. And we'll put the unit on there because why not? All right. Hey, look, there's a decimal, so we have to use the decimal rule. So these are sig figs. And then anything to the right is also a sig fig. And there you go. Everything on the left over here, this was all placeholders. And then the last number that we have is 500, but there is a catch here. Notice that it's not just 500, it's 500 with a dot after it. And that dot is not a typo. That dot is intended for you to say, oh, there's a decimal point. The decimal rule must apply. And so you would say, okay, well, this is a sig fig, and everything to the right is too. So there would be 3 significant figures. To contrast, If I did not write the decimal point here, and I just wrote this, then this is the only sig fig, and these are now placeholders. So it is possible to manipulate the number of significant figures you report your answer to, but still have the same number, right? And that makes sense, because if I wanted more than 3 sig figs, I could just do something like this, right? So this would be 5 sig figs, because I just keep adding extra zeros at the end. Now a question does arise, how do I get 2 sig figs out of here? And the answer is, if I want these to be significant but this to be a placeholder, there's no really good way to do that, right? Because if I put the decimal point in the middle here, now it's not 500, it's 50, right? So what do I do? And the answer to do this, which we're going to talk about later on in Chapter 2, is to use scientific notation and write it like this. Which seems really like, what the hell? However, that is what we have to do to get the correct number of sig figs. And that might come up at some point, but just not right now. That'll happen later on. All right. Any questions about sig figs? That's the sig figs lecture. Everyone dreads this because it's weird. Like, I'm taking numbers and I'm ruining them for you. Haha, did you like math before? Not anymore. That's a common response here. Why is the 0 to... I can barely read that. Hold on. Let me open this up. Why is the 0 to the right a sig fig? Those are the rules for decimals. So when we have a decimal in the number, any zeros to the right of a non-zero digit are also significant. I never liked math. That's a fair response to give for this part. I gotta find the right window here, and then we'll go to this. Okay. What am I looking for? There we go. Not having everything on the same screen is very confusing to me. There we go. All right. So now that we understand significant figures, we have to use them in mathematics, and this is where we break everyone's brains, because everybody thought, oh, I know how to add numbers together. I know how to multiply numbers together. You punch in the calculator, right? And there's a little bit more to it than that. For every math operation you do in Chem 121 and science classes beyond, so if you have to do math and bio, you'll have to follow these rules too, you need to worry about sig figs. And the reason for that is we're not just adding arbitrary numbers. We are adding measurements together, or we are multiplying measurements together. And the rules of sig figs imply that some numbers are known and some are not. So what we're going to do is we're going to look at these two examples, example A and example B, and these are unique. They have different rules. So we're going to look at one and then the other, and then we're going to do math and follow sig figs rules with math, okay? So I'm going to give you two sets of rules here that you have to learn. The first set applies to addition and subtraction. The second set, multiplication and division. But the rules themselves are not interchangeable. They are unique to the given operation. So you do have to learn the addition subtraction rules separate from the multiplication division rules. If you mix them up, you get the wrong answer, and that's no good, okay? So be careful about this section. Make sure you compartmentalize your notes effectively so that you don't accidentally swap them. All right. Everyone has done a problem like this at some point. Probably like second or third grade. you were taught that, oh, you can add multiple numbers together. And what you would do is you would just add them straight down, right? So you get to a situation like this. Well, what do I do with these blanks? Well, you just treat them like they're 0, right? And so you just add straight down. So 8 plus 4 is 12. So carry the 1. 8 plus 6 is 14. Plus 4 is 18. Plus 1 is 19. Carry the 1. 9 plus 3 is 12. Plus 2 is 14. Plus 1 is 15. Carry the 1. So much carrying the 1, right? There you go. That's the number that you would have reported when you were 8 years old, and your teacher would be very proud of you. Today, you'd report this number to me, and I'd be like, wrong. Because I'm not just any teacher. I am a scientist, and I'm teaching you to science, right? Why would this answer be wrong, though? And the answer is this statement right here. If the numbers that we're using in this expression are measurements, then these digits and these blank spots are not known. And if they're not known, they're not 0. They're any number we want them to be, right? Now, what does that mean? Well, if I add 1 to any random number to any random number, is the answer going to be 1? No, it's going to be some random number. We don't know what it'll be, right? So I can't write this number here. I don't know what it is. If I add 8 plus 4 plus a blank, and the blank is any number, will this number down here be 2? No, I don't know what that's going to be, so I don't get to write it. But over here, 8 plus 6 plus 4 plus whatever jargon that we did know over here, does that equal 19? Yeah, it totally does, right? So I do get to keep that number because based on what I had over here, this number is all known. And whatever this number ends up being is not going to affect this result. At least not appreciably. It's not going to randomize it. It might be 1 higher or it might be 1 lower. But it's still reliable enough. I know that it's probably going to be about that. And so that would be the answer that we would report. Now, what exactly did we just do? Here's our algorithm. What you're going to do is you're going to find the first place in your numbers, and I say numbers, all the numbers, where every number has a digit in it. And that digit is a significant figure, okay? So let's work from right to left here and look at that. So I'm going to look at this place right here. I'm going to look at the thousands place. Is there a sig fig in every number? Well, there's not one in the top or the bottom numbers, so no, that did not work. Let's look at the hundreds place. Is there a sig fig in every number? Not in the top number, right? So no, that's no good either. But what about the tenths place? Hey, that's the first position that I go from coming from the right, where every number has a sig fig in it, in that place. Then what I'm going to do is I'm going to do addition like you normally would. Treat the blanks as zeros, and we'll just write down the number. And then finally, once you have that number, round to the place that you have selected. And there's your answer. This will account for the fact that there are blank numbers in your values that you don't know what they are. They could be any digit. And how will they affect your results? Well, we don't really know for sure, right? But the effect that they will have on the known numbers is going to be minuscule down here. And so this is fine. When I get to this number right here, remember that the first 3 numbers are known, so these are all known. And then the last one is estimated, right? And we did estimate it because changing this digit up here, if it's a 0, then we know that that last digit in our answer is going to be a 9. But if that blank up there was itself a 9, that would cause us to have to carry a 1, and so the 535.9 would increase to 536.0. But it's still relatively close to 535.9. We didn't completely ruin our answer by making that question mark in the next place over as large as possible. So when I say that the last digit is estimated, it's accommodating for that error. The answer might actually be slightly bigger in this place, but not so much bigger that this 9 isn't a good guess. Okay? Hopefully that makes sense. So that's the process by which we do this. Let's have you try that with this example here. Now I'm doing subtraction, but subtraction is the exact same rule set. So write out on your piece of paper this problem. You do have to set it all up vertically. Do the subtraction and then follow the Sig Fig rules. Report the correct answer to this problem to the appropriate number of Sig Figs. Okay? I'll give you 1 minute to do that, and then we'll go over the answer in just a second. All right, we had one answer come in the chat. There might be a few more coming in because there is a bit of a lag for this. But let's go over the answer here. Oops, not even on the screen. All right. So I need to set up this problem vertically, so we will write that down like this. And so what I'm going to do is I'm going to start from the right. Is there a digit in every position in the thousand or the hundreds place? Well, there's nothing here, so no. How about the tenths place? Yeah, there is. There's this 8 and this 7. So we're going to round our answer to this spot once we're done. And now I'm going to do the subtraction like normal. So 3 minus 0, 0, which we'll treat this blank as 3. 8 minus 7 is 1. 4 minus 0 is 4. And I'm going to round to this spot. So the answer I would report is 4.1. All right, let's do another one. I'm going to give you these two numbers, and I want you to add those together and tell me the results. And while you're doing that, I will get this set up because it's going to take me a second with this monitor situation here. So I have to keep alt-tabbing back and forth to make sure I get the right number here. Now, I will warn you, be careful on the second one, which digits are Sig Figs and which ones aren't. Because remember, when you're working from right to left, you want to find a Sig Fig in both numbers. Okay? I'll give you a minute to think of the answer. Write it out. Good luck. All right, we got some answers in here. So we got 7,400 as the answer. Let's see if we can get to that. So, first of all, let's see. Hundredths place. Is there a blank? Yeah. How about the tenth? Or sorry, that was the thousandths place. Hundredths place blank. Tenths place blank. What about the ones place? Well, these zeros are placeholders. They're not sig figs, so they're essentially the same as blanks or question marks, right? So the first digit that we get to that we can actually have known numbers for both things in is the hundreds place. So when I do this addition here, 7th, oops, I should start over here. 228, 934. We would round to the hundreds place, and so the number that I would report for this answer is 7,400 because all those digits and the decimals get basically trashed because we don't know what the numbers are in 7,300. Now that's a little bit frustrating, it seems like, but this is just how the rules shake out to be. Now, if for an even more frustrating example, try this one. What's 3,000 plus 6? And because we're running out of time, I'll do this for you. If I'm going to start looking at places, what about the ones place? Well, no, these are all placeholders. So the first place that I get to that I actually know the numbers, because I know I have 0,000, I know I have 3,000, we have to round to the thousands place. So in this class, 3,000 plus 6 is 3,000. And you're probably looking at it and then going like, what? That's so dumb. That's not how numbers work at all. I'm clearly adding something, so why does it do nothing? And the answer is it has to do with how the magnitudes of the numbers shake out. I realize we're going over class time. We'll finish right after this analogy, but so I apologize for going a little over here. This is just how magnitudes work when you have something that is a high magnitude with a low magnitude, and you're trying to resolve them together. 3,000 is not well defined. Counting in thousands is how do I want to say this? When you count by 1,000, you're making a very, very rough estimate. If I count the number of people in Seattle by thousands, I'm clearly ignoring hundreds of people when I round in one direction or the other, right? But if I count by ones, I'm being much more precise. So 3,000 is a much less precise number. When you have numbers that are very precise and imprecise, or not precise, the precision of the good measurements gets kind of screwed over by the bad ones. And that's just because of how magnitudes work. Let's do another example here. let's suppose that instead of taking Chem 121, you decide to play the lottery. And lo and behold, you win. And you win this many dollars. You win $656 million. Congratulations. Drop the class. You do not need this anymore. You are set for life. However, you are still new at this millionaire thing, so you celebrate in the only way you know how. You go to the drive-thru at Burger King, and you buy a Big Mac for $7.99. How much money do you have left? Is it $655,999,994? No, nobody gives a shit about these digits anymore, right? You have $656 million. You don't care about the hundreds place. You could throw away $10,000 and you wouldn't even notice it. Yeah, I'll just go buy a car. I'll go buy 10 cars. I feel like having one for every day of the week. And then 3 more for my dog. Because when you have $656 million, you don't give a shit about those digits anymore down there, right? They're too small to affect it. And it's the same circumstance up here. 3,000 is too big for 6 to affect. We can do this as the visual example, too. Let's suppose that you are working at the M&M's company, and you have a bin that holds 1 million M&Ms in it. And so I would estimate if these were M&Ms, there would be about 500,000 in there, right? Now, in the middle of the night, a very, very hungry mouse eats about 40 M&Ms. How many M&Ms are there now? It's still 500,000, right? Because the amount that disappeared because of the hungry mouse, way too tiny to be affected by the scale that we're looking at, right? I would be more concerned about the fact that there's a mouse eating chocolate in the M&M's factory and how sanitary that is, and also the health of the mouse, the poor thing, rather than the impact on the total number of M&Ms on the bottom line, because the tiny amount that we removed doesn't affect the whole thing. It's just too small. All right, so when we do addition and subtraction with Sig Figs, we get weird results if the magnitudes differ a lot. And that is by design, okay? So don't feel that that's super weird, because in some ways it actually does make sense. And we've designed it to be like that, okay? But just make sure that when you are doing addition or subtraction and the numbers are very, very different from each other, that you aren't falling into the trap of, oh, let's keep all the digits. Because if you don't know what the digits are, you don't get to keep them. All right, I think that's all that we have time for today, because I've already gone over by like 8 minutes. Yeah, so I'm going to put the title card up here for today. We're going to resume tomorrow with multiplication. The one thing I do want to comment on is that there is going to be tonight, I'm going to put a quiz on Canvas for Chapter 1. For all content in this class, you have a week to do the thing, okay? So the quiz will go up tonight. It will be due next Monday. And by due, what I mean is that will be the due date, and then there's one day after that if you absolutely need it, that before the assignment closes for good, okay? So the first quiz will go up. It will be on Chapter 1. I will get to that tonight after I come back from buying a monitor. I'm looking at where I'm trying to put the new monitor, and I don't know how this is going to work. I'm probably going to have to disassemble a bunch of stuff, so it might be a little bit later than I hope, but I will worry. I'll cross that. That's a problem for future Wes. So until then, that will be up sometime tonight. Tomorrow, our lecture will continue from where we left off today. I apologize again for the delay in getting the stream up. We'll see you tomorrow. Hopefully no more problems. Take care.